Hello, Professor. Our group number is 6, and my name is Patel Nirav, and our topic is criminal violation analytics. In table of contents, we have first is about the project, second is the team, third is our timeline, and then we have the activity report till date, followed by challenges and proposed solution, and at the last we have project cost. So, introduction. The Criminal Violation Analytic Project aims to analyze criminal violations that happens in past few years in some of the main major cities in Canada. Objective and goal includes the identify the most common types of crimes and the subcategories, analyze year-over-year trends, develop visualizations and predictive models, and provide data-driven recommendation to improve public safety measures. Here is our team of Vrund and Viswa handling our SharePoint site. Parth is maintaining technical work and meeting with clients, and Nira working on weekly reports and presentations. If I talk about my timeline, we can see that our project status is on track. We are currently working on testing phase. Next, if we talk about activity report till date, we have collected the data from Statistics Canada. We have performed some data cleaning and pre-processing steps with various imputation techniques, developed some preliminary visualizations and conducted regular meetings and also developed a dashboard in Power BI. So I talk about data cleaning. There are these steps include the cleaning of the data. This and the step two we have data exploration, which is used to understand its structure, variables, and distributions. So here is our descriptive statistics of all our data sets with and also the printed the computed values. Next we have the bar chart that displays the various type of assault organized by age categories. Then we have the box plot of assault subtypes with count. Here is the histogram that represent all our different columns of index, report year, count, and object ID. Next is the distribution of count. Here is our correlation matrix heat map of the data set. Next, we have the ongoing current live cases throughout our 4 cities that we have included. Here is the pie chart that describes the different assault subtypes distribution. Here is our pair plot, which describes the dataset with the help of a seaborne plot. Here is our pair plot visualizations of our columns count and report year. This is our bubble chart of resistor rest according to the different age. Here is our next second bubble chart of assault piece officer according to the different types of age. And here is our scatter plot which shows our crime incidents over the years. Then we have the stack bar chart which shows that the crime distribution is increasing year by year. And in 2020 this is the max having crime category of against the person. This is a crime distribution over the years with different types of categories included. Here is our linear regression of our predicted versus actual. Here is our SharePoint site dashboard, SharePoint site task list, action items, time sheets, and minutes of meeting. Here is our crime violation analytics dashboard. So there are some challenges of data capture inconsistency, limited access to certain crime data, complex crime classification, time constraint, creating effective visualization, and the recommendations are according to there. Here are the project cost. And thank you. Now we will directly move on our Jupyter notebook where we will show live codes. Yeah, here is our Jupyter notebook code. So first of all, we use the code for loading the dataset into the Jupyter notebook and describing the dataset. Next step, we have performed data cleaning in which we have dropped all the rows with the missing values. And then here is our steps to remove duplicate data. Thank you.
Hello, my name is Vrund and I will take you from the here step 2 data exploration. In data exploration, we have examined the data and understood its structure, variable, and distribution. As we can say, we have imported pandas as PD to examine the structure of the data, and we have printed data structure where we can say that column, none, null, count, and dtype is printed. In the next step, we have examined the columns where each of the columns name is distributed and printed. On the next step, we have displayed the first few rows of our data frame where we can see that the first few row of 1 to 6 is printed over there. And in the next code, we have displayed the last few rows so that we can understand the data efficiently. On the next, we can say that we have printed for look at the data type for its data type for each of the row so that we can easily understand the data. And then we have counted the number of missing values, and we have possibly counted that there are none missing values in our data set. Then we have filtered and sorted data with pandas. As we can see that we have saved the filtered data into a filter data frame by making a copy of original data frame, and our original data frame remains untouched and the clean data is still here, which we can use and experiment in our data. And in the last, we have sorted the data by a column in descending order so that we can understand how data works. Thank you.
Hi, hello everyone. My name is Vishwa Mistry, and I'll walk you through the step 3 of the project, which is descriptive statistics. First, we have imported all the necessary libraries such as Panda, NumPy, Matplotlib, and Seaborn for data science for EDA and generating insights. After that, we have generated descriptive statistics using data describe, which provides a summary of the data set, including the mean, standard deviation, minimum, maximum, and quartile values. This step is essential for understanding the basic distribution and characteristic of data. Additionally, the code calculates specific statistic by applying dot mean, dot median, and dot standard deviation functions to the numeric columns. These values are printed to the console, allowing us to observe the central tendency and variability of the data. After that, we have created one variable called named df, and we have stored our data frame into that variable. After that, we have it's step 4, which is visualization. We have created a bar graph using matplot to display the relationship between assault subtype and age group. The x-axis represents the different assault subtypes, while the y-axis shows the corresponding age groups. The bar are color-coded blue and red to differentiate between groups, making the visual representation clear. After that, we have focused on specific conditions. It selects only the youth age group and filter for particular assault subtype, namely other and assault racist arrest. This filtering helps narrow the analysis to a specific demographics, making the insights more targeted and relevant. The filtered data is grouped by assault subtype, and the counts are summed by using group by and sum function. And the bar graph is then plotted to visualize the frequency of these assault subtypes within the youth category. We have also created box plot with Seaborn, which visualize the distribution of assault subtype counts. Box plots are particularly useful for identifying the spread of the data, the median, and potential outliers. The x-axis represent the different assault subtype, while the y-axis display the count values. Thank you.
Hello, my name is Parth Patel, and I'm from here. I'm carry forward. So here is the histogram, in which the matplotlib is the library and the functions is used to display the data of histogram. So here I use the data, which is the variable name of the dataset, and hist is the function which represents the 4 datas, like 4 diagrams: index, report year, count, and object ID. Next is the another histogram which distributions of count, where X label represent the count and the Y label represent the frequency. So here you can see the count and the frequency. Next is the heat map, where I imported the Seaborn library and the Matplotlib. And firstly I check the columns and the data type. Then I represent the correlation matrix of the dataset, like object ID, count, report year, and index. Next is the heat map on map, where I imported few libraries to represent cities on the map. So after executions of this of the code, it stores into my folder here. Here it stores in my dataset, in my folder, and here you can see the highest value. It shows the Etobicoke, which is 50,600. Second highest is the Vaughan, 42,770, and third highest is the Scarborough, 41,499, and the last is the Toronto, 39,660 incidents. So next, move towards another visualization. It's a pie chart which represent the assault subtype, which represent all assault subtypes here. And the highest is the 37.3 other, and the second highest is the assault resist arrest, which with 22.9%. Next is pair plot, which represents the all columns of the dataset here. Next is another pair plot visualization, but here I represent count and the report year. Count and the report year with category times against the person. Next is the bubble chart, assault resist arrest. In this I represent the age cohort and the count of incidents, which represents from 12 to 17 to 65 plus. Next is the another bubble graph, but here age group and the sum count as well. Age group adult to youth and the count of incidents. Next is the last bubble chart for assault peace officer. After execution of the code, I display the output here, age and the count of incidents, which represents from 18 to 24 to less than 12. Here you can see peace officer. Next is the visualization for scatter plot, where represent the report year and the count of incidents for starting from 2014 to 2023. Here you can see the crime incidents over the years. Next, I added the city into dataset, where 4 cities majority in display: Scarborough, Etobicoke, Toronto, and North York. Then I started with the stack bar graph, where crime distributions occur in the different years, 2014 to 2023, total crime counts. And here I only added the crime category, but second stack bar graph I added this assault subtype as well. So here you can see the distributions of the crime. Next, I go to final step of our project, which is models. Firstly, linear regression. Here is the linear regression, and the model, after fitting of the model, I get the output of this score, and here is the visualization of my linear regression. Lastly is the decision tree, where after building the model, I get the score of prediction, which is the evaluation model 100%, and I represent the decision tree here. And after execution of this code, it exported to my to my folder. Here it stores, and the final representation of the code is here. Decision tree is here. Thank you.